So today we will discuss angles of elevation and angles of depression. The first thing you'll have to do is make sure that your calculator is in the correct mode. So if you press the mode button, make sure your black box is around degrees. Okay? So the angle of elevation is defined as the horizontal up, and the angle of depression is always the horizontal down. So the way this works is, let's envision you're on the ground and you are looking at an object on the top of a building. So what I would say is your angle of elevation, your line of sight horizontally adjusted to the top of the building would be your angle of elevation, whereas angle of depression would be if you're at the top of the building, your line of sight horizontally adjusted to seeing an object on the ground would be your angle of depression. The good news is that because of the fact that we have a pair of horizontals, and I'll make an assumption the horizontals are parallel to each other, you end up getting here, because you have parallel lines, you could say that you have a nice pair of alternate interior angles. So long story short, what does this mean? It means the angle of elevation and angle of depression are the same. Let's look at a couple of examples. So let's say you have a ramp that's 125 meters long. I'll draw a picture. Now a ramp is drawn to an angle of 39 degrees of angle of elevation, and that's with the ground. And the ramp is 125 meters long. We want to find the vertical distance. So I have to use SOHCAHTOA because we're given angles and sides. And from the angle of 39 degrees, I would say that the x is the opposite, and I would say that the ramp is the hypotenuse. So that would be sine. The sine of the angle is equal to the opposite over the hypotenuse. And when you cross multiply, you'll get x is equal to 125 sine 39. So I'll go to my calculator, 125 sine 39, and they want this to the nearest meter. So to the nearest meter, I would say that would be 79 meters. Okay, let's look at example number 2. In example number 2, it says we have a plane that's 3 miles above the ground. So I'll draw a plane here. The pilot sights an airport at an angle of depression of 15 degrees. Okay, so here's my right triangle. The plane is 3 miles above the ground. Okay, here's the runway for the airport. And the angle of depression is 15 degrees. So remember how that works again. For the angle of depression, that's always going to be the horizontal down. So what I would do is I actually would not look at that angle as 15 degrees up here. What I would say is I would put it in as the angle of elevation, because remember you have those alternate interior angles. And the question says, what is the distance between the plane and the airport? So I'll put a direct distance x there. Okay, so from the angle that's given to us, which is the 15 degree inside the triangle, the 3 would be the opposite and the x would be the hypotenuse. So this should be sine again. The sine of 15 is equal to the opposite over the hypotenuse. Now keep in mind this time that when you cross multiply, you'll get x sine 15. So it's going to be x sine 15 is equal to 3. So I'll divide by the sine of 15. So x is equal to, okay, I go to my calculator, 3 divided by the sine of 15. And they want this to nearest thousandth, so it'll be 11.591. Okay, and that would be miles. Okay, let's look at example number 3. So Jerry now is standing 100 feet from the Empire State Building. Okay, so let's draw Jerry here. So here's Jerry. Now he's 100 feet from the Empire State Building. So he's 100 feet away. Here's your building. The building is 1,453 feet high. We want this time the angle of elevation. So what's the angle that Jerry's looking up at? So from the respect of the angle, 1453 would be the opposite, and the 100 would be the adjacent. So that should be a tangent question. The tan of the angle is equal to the opposite over the adjacent. Remember, please, when you want to find the angle, this is where we have to use the inverse. We did this in the previous lesson last week. So the tan inverse of 1453 over 100. So what I do for that is I press second tan 1453 divided by 100. And keep in mind, this is your angle. So you're looking at about 86 degrees. If we assume that 90 degrees would be looking straight up, that would mean that 86 degrees would mean Jerry is probably pretty close to being, right at the front door of the building. All right, a man stands on a cliff 350 meters high. Okay, so let's say here's your cliff. Okay, here's your man at the top. The cliff is 350 meters high. He sees a boat out at sea. Okay, so here's our boat. Okay, and the waves. Okay, and the angle of depression. All right, so let's draw our right triangle here. And again, the angle of depression is the horizontal down. That's 26 degrees. Remember, we don't want it outside the triangle. We want it inside the triangle. So I'll mark 26 as the angle of elevation. And the question's asking how far is the boat from the base of the cliff. So that's going to be, the X is going to be on that lower part of the triangle. All right, so from the 26 inside the triangle, the 350 should be opposite, and the X would be adjacent. So that's the TOA, isn't it? That's the tangent. So the tan of the angle is equal to the opposite over the adjacent. So when we cross multiply on that one, you'll end up with, I'll say, X tan 26 equals 350. I'm running out of room here, so I won't write this out, but you'd have to take 350 and divide by the tan of 26. So let's take a look at that. 350 divided by the tan of 26. So that would mean that the boat is about, and they want this nearest tenth, I'll say 717.6. All right, and that would be meters. This is a fun story. Mr. Franklin proposed to his wife on a hot air balloon. When he proposed, the altitude of the balloon was 542 feet, and the balloon has traveled 712 feet. Find the angle of elevation. Okay, so let's set up this scenario. So here is the balloon with Mr. Franklin and his fiancée inside of it, and the altitude of the balloon. Altitude's the height. All right, so I'm going to label that as 542 feet, and the balloon has traveled 712 feet. Find the angle of elevation. Okay, so let's turn this into a right triangle. We want the angle of elevation, so that's always the horizontal looking up. Now, that my comment here about this, if the balloon's traveled 712 feet, I'm kind of envisioning that as the distance is traveled from being on the ground, right? This is the ground, to its current position. So I'm going to put the 712 as the hypotenuse. That is slightly ambiguous. I could see how some people might want to label it as the horizontal, but I'll keep that literally the distance, direct distance that the balloon traveled. So with that being said, the 542 would be opposite the angle. The 712 would be the hypotenuse, wouldn't it? So that should be the sine. The sine of the angle is equal to the opposite over the hypotenuse. Remember, please, this is where you have to do the inverse, okay? So you're going to do second sine of 542 divided by 712. So second sine 542 divided by 712. And they want this to the nearest degree. Okay, so I would say x would be about 50 degrees. Okay. A ladder leans against a house, making an angle of 30 degrees with the ground. All right, so let's draw a picture here. You know, the ladder is kind of leaning, so here's your ladder. Here's your house. Not really a great diagram, but I think you get the idea. All right, and it makes an angle 30 with the ground. So 30 is with the ground. I put that on this angle of elevation. Now the foot of the ladder, that's the base, is 7 feet from the foot of the house. That will be on the bottom. We want to know how long is the ladder. Well, according to the labeling, I would probably say that the 7 then would be adjacent to the angle, and the x would be the hypotenuse, wouldn't it? So that should be a cosine question, right? The cosine of the angle is equal to the adjacent over the hypotenuse. So that's going to be x cosine 30 is equal to 7. And if I divide by the cosine of 30, 7 divided by the cosine of 30 should give us about, and they want this to the, it doesn't say, so I'll say x is about 8 feet. It doesn't specify. All right. And then finally in number 7, find to the nearest tenth of a degree the angle of elevation. If you're standing 400 feet away from a building that's 850 feet tall. All right, so let's draw my right triangle here. Okay, I'm going to be standing down here on the ground. Here's your building. I want to find the angle of elevation. Now, I'm standing 400 feet away. The building is 850 feet tall. So the way I would kind of interpret that is I would probably say that the 400 would be adjacent and the 850 would be opposite. There's no hypotenuse in this case. So that should be the tangent. The tangent of the angle is equal to the opposite over the adjacent. All right, so we got an inverse here. So I'm going to do the tan inverse of 850 over 400. So I'm going to press second tan of 850 divided by 400. And that would tell us what the angle is. The angle would be about, and it says nearest tenth, so I would say 64. Let me write that, 64.8 degrees. All right, I hope you found this helpful. If you have any questions, let me know. And I'll talk to you guys soon.